Greetings, Ubiquity University students. It's Andrew here with my student Jack. We're going to be giving a little introductory video for you guys to just give you a visual representation of what you might expect in this course. So sit back, there's no need to take notes right now, relax and enjoy. So, as you can see on the screen, we have what's called a generic picture of an over-popularized atom. Now, you probably have seen this picture on logos, on science shows, on these diagrams, and it's a little misleading. This is supposed to be the building blocks of everything. These are the components that make up the chair that I'm sitting in right now. These are the components that make up you, the components that make up me. And we can see that there's these little blue balls in the middle, and there's these little red balls in the middle, and that is what we would call the nucleus. And in this representation, we see these purple balls that are circling in kind of a roller coaster elliptical pattern, as it looks like. And those purple balls would be representative of what are called electrons. The intermass is called the nucleus, where we have protons and neutrons. Now, the thing is, this diagram, it's a little misleading, okay? And because in fact, electrons are not spinning in a predictable, in a predictable trajectory like this. There's actually what are called orbitals, and these orbitals are a place where we can predict the probability of an electron being in a certain area at a certain time. So let's take a little step back here. Let's go to this next slide. Let's zoom out. Now, this atom is now very small, as we can see, this sort of generic made-up picture of this atom. And let's take a real element, okay, from the periodic table. And the periodic table, as you guys will learn about, is this very beautifully assembled diagram of different elements arranged in a predictable and logical manner that scientists use to study science, to study everything from chemistry, obviously, to physics, to biochemistry and biology. Now, let's get, like I said, a real element, and this element is going to be carbon. Okay? Now, Jack, what you're asking me is why carbon? Right?
Yeah, exactly.
Okay. Well, in fact, we are made of carbon. All life is based off this one element. It is the central element to life. Now, as you're going to learn, there are other elements too that are high in concentration in living systems, like hydrogen, oxygen, nitrogen. Okay, many others. But carbon is really the backbone of these molecules. So you can see here in this picture, we can see these purple little ellipticals that are sort of overlapping, and we can see these blue ellipticals that are vertical. That vertical means up and down, okay? And what it is that these ellipticals are a representation of the probability that an electron will be in this area. Now, an electron has a negative charge. All of this stuff you guys are going to be learning in detail, okay? But for now, let's just go along with this. Electrons have a negative charge, okay? And two atoms bind to each other. And in this case, these two carbon atoms are bonding to each other because they are sharing electrons with each other. And we can see that the electrons are being shared up here by these blue orbitals, and down here by these blue orbitals, and in the middle by these pink orbitals. Now, this is a representation of two carbon atoms, and we can see this is forming a molecule right here, okay? But not many things are just made up of just two atoms, okay? Besides, you know, the most common molecule, water,
Exactly.
okay? There's another common molecule called carbon dioxide. It's very few atoms within those molecules. but a lot of the organic molecules that we're going to be studying are a lot bigger. So let's take a moment and turn these carbon atoms sort of on their side, and now let's overlay another molecule on there. Now, this is getting a little bit more complicated here. It kind of just looks like a dirty picture. It just looks like a picture that's just sort of scribbled with shapes. As a very famous chemist used to call them, his name was Alexander Shulgin, he would just call them dirty pictures. And he had an entire documentary based off these beautiful drawings of these molecules and of the different molecules that he would synthesize that, again, relate to this course because they altered consciousness. He created drugs that altered consciousness in different ways. Now, you can see, Jack, in this molecule here, every time we're changing a direction, that is where a carbon atom lies. Okay? So we can see here there's a 6-membered ring here. 1, 2, 3, 4, 5, 6. Okay? And then to directly the right, we can see there's a 5-membered ring here, like a pentagon shape here. Now the different colors here are representing different atoms besides carbon. So this red one here is an oxygen atom, and this blue one here is a nitrogen atom. And actually later in the course, you guys are going to be learning how to draw all these different atoms. Okay, so now we can even begin to look. Now we've examined, just in this little bit, we've examined the relationship between a single atom, between two atoms, and now then we've examined the relationship of how these two atoms formed a molecule. Exactly. Any questions?
No, I'm good so far.
You're clear? Okay. Must mean I'm doing a good job here. So what we can now do is say that there are some molecules, we even prefaced this before, that are more complicated than other molecules. So let's again zoom out. It's pretty fancy, right?
It's nice.
Okay, and let's overlay another molecule. So now you can see that there's a 6-membered ring, another 6-membered ring, another 6-membered ring, and you can see that there's even some double bonds here. There was even a double bond in this last molecule we saw. We can see these little white things sticking off. Those are hydrogen atoms. Again, we see more nitrogens, those red things. And what I say is, this is again a more complicated molecule.
Now, what does this make?
That's a good question. Let's take one step back. Go back to this more simple molecule. We forgot to even say what this molecule is. Do you know what it is?
No, I'm not clear.
You're not clear?
No.
Well, for some of you who have a science background, you might know that this is a neurotransmitter, which is a chemical in your brain that changes consciousness, that has different chemical properties and participates in different chemical reactions in the brain. And this is one of the popular neurotransmitters. This is one of those neurotransmitters that gets all the credit, and it's called serotonin. Okay? You're always hearing about how cool serotonin is and how cool dopamine is. You've probably heard before that dopamine and serotonin are involved in pleasure. Serotonin is especially involved with mood. And people might think, oh, dopamine. That I only get a dopamine rush when I take some drug or or when I'm having sex or something like that. Well, in fact, dopamine is involved with a lot of other reactions besides that. When your cell phone buzzes in your pocket, you're getting a shot of dopamine in your brain. When you eat a little piece of chocolate, when you see someone that you love, when something exciting happens, that's all controlled by dopamine. And again, serotonin is more involved in our moods. And this is serotonin, like are you feeling depressed today? Are you feeling happy? Again, scientists are not sure about all this stuff, but we really believe that these neurotransmitters and the chemical composition of our brain is correlated to our mental states. Okay, so we're a little off track, but that's okay because we're going to be having a lot of these side conversations during this course, and you especially are going to be encouraged to have these conversations with your fellow students. Now, again, let's take a zoom out, and we see that this new molecule here that we've put fits directly on top of serotonin. And I will say that that must mean that the serotonin molecule and this larger molecule have something in common. We can see that they share physically these two rings, and that's why they overlay very nicely with each other. And we can infer that because they share these two rings with each other, that they must be doing something similar in the brain. And in fact, this larger molecule is called lysergic acid diethylamide, better known as LSD. And what is the most amazing thing about this is that after the discovery of LSD in the late 1940s by a man named Albert Hofmann, we actually learned as scientists a lot about how serotonin worked in the brain. Okay? And we did that by studying how LSD was interacting with serotonin serotonin receptors. Now, is it just a coincidence that serotonin and LSD are fitting together in this way? No. Again, a central theme of this course is we are examining the relationships between these molecules. So, let's, any questions, Jack?
Not so far.
Man,
Very clear.
you are such a good student. Okay. So let's take this molecule right here of our LSD molecule and let's put it in its natural habitat. Just kidding. It's not in its natural habitat, but it is currently in a biological system. It is in a biological. It is in a biological organ, and it is in the brain. We can presume right now. Okay. So all these green things that you see here are called phospholipids, and those phospholipids encompass the outside shell, we could say, of cells. Now, cells are entities that make up life. Plants have cells, mushrooms have cells, you have cells, your cat has cells, everything has cells that is alive. Now, these cells, like I said, are surrounded by phospholipids. And what happens is molecules can interact with the outside of cells and cause those cells to do different things. Now, like we said, the brain cells that are inside of our head are called neurons. They have what are called proteins within inside of their membranes, and in fact all cells have proteins within inside of their membranes. And different neurotransmitters or drugs can bind to those cells and change the way those cells are interacting with different cells. Okay? And you can see how this is getting very complicated. Okay? And they can thus change the chemical composition of the brain, which we believe can change behavior.
Makes sense.
It does make sense, but it does require some thought it does require this logical trajectory, and this, like you were saying earlier, this linear thought pattern of here is an atom, this atom is creating a molecule, these molecules are interacting with each other, these molecules even form macromolecules. And again, these macromolecules and these molecules interact with each other to form living systems. And we can even go so far as to say, we can zoom out and say that this cellular membrane that we're looking at here could be part of a neural network, could be part of brain cells. Okay? And you can see these red entities right here. This is what you would call an artist representation. These are not real brain cells, but these are called synapses, and these are the places where brain cells communicate with each other. Okay.
So that's how we function.
I mean, we believe. We can't say for sure, but like we were saying in the other movie, that we have connections in our brain, and these connections are called synapses. And there's somewhere between 80 to 100 billion synapses in the human brain. Okay? And in between those synapses is where neurotransmitters and drugs and different entities alter synapses and thus alter the state of neurons. And because those neurons are changed, that allows us to do different things. That allows us to remember things. That's like memory. That allows us to talk. That is allowing you to comprehend what I am saying. And as I speak to you right now, your neural network is changing. Ha ha ha, I'm changing your brain right now. You can't even do anything about it. And that is the crazy thing. And when I say change your brain, literally these neurons are remodeling themselves. Now, I am throwing all this stuff at you, and you might feel like, oh, I'm feeling like a little bit lost right now. But that's okay, because all of this is going to be explained in detail by experts in scientific videos that we're going to be watching. Okay, so let's bring it back here for 1 second. Okay, looking at these or this artist representation of neurons. Okay, and let's remember that these neurons make up a brain. Okay, and here we are. Here's another sort of classic representation of the brain with many gears. And a lot of the time we just think of the brain as these individual components that are sort of like doing their own thing. Now that's not really how we should be looking at this, and it's what scientists are really coming to, that in fact the relationships between these neurons are actually the most important thing. And so let's take it all the way back. Again, we've looked at the relationships between atoms, molecules, how molecules are interacting in systems, how molecules are forming neurons, how neurons are forming the brain. Okay? How these neurons, the relationships between these neurons are forming how we interact with each other. And now we can take that we've formed this very complex system called the brain, which many scientists say is the most complex structure in the universe that we know of. Now we have billions of people on the earth interacting with each other. We have formed again more relationships. Let's examine how these people are interacting with each other. Let's not focus on individual people. Let's focus on how these individuals are interacting with each other, and how this can apply to the world. How we can create a more sustainable world. How we can examine intricate political relationships between nations. How we can see how one action in one space can form huge consequences in another, which is called the butterfly effect. So these are all the things we're going to be looking at in this course. Again, we're going to be starting small, and we're going to be ending big. And you are going to be applying all this stuff, formulating your own opinions. You're going to be using course material to do a final project. And I, again, am super excited to dive right in. This is Module 1, okay? And you're going to be learning in this module about science. You're going to be learning a little bit about the history of science in this module, and you're also going to be learning about what's called the scientific method. The scientific method is, I'm proposing a question I might have. I might say, well, why is it that this chair that I'm sitting in supports me right here? And Jack might say, well, I have a hypothesis. That's because this chair has legs and it is supporting you. And I say, well, I think we should test this hypothesis. And I could say, let's cut the legs off of this chair and see if it still works. We find out it doesn't work. Oh, we didn't prove our point, but we now have a theory that these legs of this chair are supporting me in this. And this is a lot of how science works. So with that is what you're going to be learning here in Module 1.
I'm excited.
You're excited? And it's going to be, again, objective material in the beginning of the class, a lot of science that we're going to be learning in really fun ways. And we're going to blossom into really big and fun stuff towards the end.
Perfect.
Are you excited?
Very.
All right.
Thank
Cool.
you, Andrew.